everyone. Today our topic is about the switch principle. Because before we already talked about the data link layer protocol, and we say in the LAN network with the typical protocol is Ethernet. And in the Ethernet, we have so many devices before, like the hub, like the switch, and so on. So about this part, we will explain what is the principle of the switch. And the key point of the switch is a MAC address. If the switch wants to forward the traffic, we will check the MAC address information, and according to the MAC address table, and finally to forward the traffic out. So how to get the MAC address table? If we have the table, what's the principle? What's the action? And if the broadcast domain is too big, what is the disadvantage? If you want to get the answer, let's start to see the video.
Hello guys, before we talk about the detail of L2 switch principle, let's have see the practice question of TCP UDP principle. The question is, in the establishment of TCP connection, which should be the Y value in SYN packets? As we know, if we want to use the TCP to transfer the message, we have to establish the TCP connection at first. So this is the process how to establish the connection. And the PC1 will send out the SYN message, and this message, the sequence number is P. And when the server gives a reply, I already received the message from your side. So I will use the acknowledgement number X, and the X value should be P at 1. And I also send the message to you have the sequence number, and the sequence number is Q. And the next packet, the PC1 will send out the established message and give you the message sequence number is Y, and the value should be same with X. So finally the answer should be C, P plus 1. So this is the answer. And then let's see the principle of L2 switch. Why we need these new devices, L2 switch? Because in our network, we can divide the network according to the coverage to become LAN, MAN, and WAN. And in the LAN, the basic and the normally used protocol is Ethernet. And on the Ethernet, we usually will use a switch. So the switch is very important device for data link layer communication. Of course, switch can be divided of layer 2 switch and layer 3 switch. And this topic will only focus on the layer 2 switch. So it is necessary to understand the working principle of the Ethernet, includes what's the working flow and what's the working principle. As we know about the L2 switch for the message according to one table, this table we call is MAC address table. So this MAC address table also is very important topic on this video. First, let's see the background. Why we need L2 switch? Because in early network, the devices could only make single point communicate with each other. For example, your computer, host A, want to send some files to host B. We can use a cable to connect with each other, right? But at the same time, if there's still the other devices like host C want to do the communication with us together, in early network, this one cannot match. So, in the same physical environment, different devices can connect to only one device. And why we need the switch? Because we want to improve the transmission efficiency and simplify the network topology. We hope we can have devices, or maybe we can think we can provide some technology to make the multi-point communication possible. So that's why we need the Ethernet. For example, like this topology, if you only have two devices, two hosts, only have one network cable can connect with each other. So in this scenario, we will use new devices. Or someone maybe say at the beginning we will use a hub, right? But the hub, this only provide multiple interface, but still all the devices have to transmit in the same time only one devices. That means if you have three computers, if one is transmitting message, the other guys have to wait. So this is the disadvantage of the hub. But now we will use a new devices, we call it switch. And about the modern switch network are built using the switches. This is a new devices. And about the switch, we also can provide multiple interface. And each part of the switch belongs to a separate collision domain. What means collision domain? If all the terminals, they can send out the message at the same time, but there is no conflict. That means they located in different collision domain. And the switch can work like this one. And another one about the switch works in a 4 duplex mode. So we also can increase the speed faster. And each host connected to a port of switch excessively use the bandwidth of the port. For example, about the switch, the interface bandwidth is 1 gigabit. That means the terminal can use all the bandwidth. So now we will use a switch to connect with each other, like this topology. We have two switches and we have 4 hosts. And after we use a cable to connect with each other, we can divide them to become different collision domains. In this topology, we have 5 domains. And in the same time, all the 4 hosts send out the message. It doesn't matter, there is no conflict. But if you change to become hub, the first host is sends the message, and the rest of 3 hosts have to wait. I have to wait and detect the host A send out the message or not. Otherwise, we have to wait. So this is the advantage of the switch. So we say about the principle of the switch, the first characteristic is each port supports the 4 duplex or half duplex mode and different rates. Depends on which devices you use, because we have different series switches. And the second one is about the switch, we have to forward the message according to one important table. This one we call is MAC address table. And how to forward the message? For example, I have 10 interfaces. I receive the message from the first interface. Which interface should be selected and then forward the message out? Depends on the MAC address table. So this one is very important. Like the picture of the switch, we can provide multiple interfaces, right? And maybe lots of us focus on the main service interface, like the medium one. We will use this interface to connect with a cable and then to connect with the other network devices. And about this service interface, we also can divide it to like the Ethernet interface, like the fiber interface. And about the left one, this interface we call it console interface. If you want to do some command about these devices, you have to use a special cable, we call it console cable, to connect with the device and then to do some command, something like this. Of course, in your real network, maybe you use the other series switches. The speed, the interface number may be different, like this picture. And then let's see the working principle of L2 switch. We say about the switch, if we want to forward the message, we will check one table. This table we call is MAC address table. So how to make the MAC address table bigger and then we can forward the message out successfully? When we receive the message, we will take the source MAC address and connect with the receiving interface and then to add them into the MAC address table. Then when we forward out, we will take the destination MAC address and then to select which interface can be sent out. So this is the main process of the MAC address. And we also can divide the function to become two parts. The first one is learning record. The mapping between source MAC address and the receiving ports are recorded to build a MAC address table. So this is the first one. Pay attention, please. We will record the source MAC address and also the receiving ports, not about destination MAC address. So this is the first one. Then we will get the MAC address table. And why we need to get the MAC address table? Because we have to forward the message out. So the second function of the L2 switch is we have to look up the table, and according to the table, we have to forward the message out. And in this process, we will take the destination MAC address of the packets and then match to your MAC address table and find the special interface and then send the message out. So these are two main functions of the L2 switch. And later, the key point is how to get the MAC address table and how to forward it. And after we get the MAC address table, we will have three actions. The first one is forwarding. Forwarding means when we take the destination MAC address and match the MAC address table, and this MAC address exists, and then we will directly forward the message out based on the special ports. For example, if we have 5 interfaces, and we receive from the first interface, and after we match the MAC address table, finally the message will be sent out on the 4th interface. And the second action is flooding. Flooding means when we take the destination MAC address to match the MAC address table, but we can't find anything, right? And how to forward the message successfully? We will do the flooding. Flooding means I will send the message out of all interfaces, but pay attention, except the receiving interface in order to avoid the loop. So, also same, if we receive the message and then we cannot match the entry, finally the message will be sent out from port 2, 3, 4, 5. This is flooding. And the third action is discarding. If the destination MAC address of the data frame is a MAC address mapping to the receiving interface, finally the message will be discarded. That means, for example, I receive the message from first interface and I take the destination MAC address to match the MAC address table. Finally, I find this destination MAC address also is connected with the first interface. In this scenario, the L2 switch will not send the message out again. I will directly discard. So these are 3 actions of the L2 switch. And later, let's see the detailed process. First one is how to building a MAC address table. About the MAC address table, the main parameter, first one is a MAC address. The second one is a port. At the beginning, when a switch is just started, there is no entry is MAC address table. And then maybe PC1 will send out the message, and the source MAC address is PC1 MAC address, the destination MAC address OF. Maybe this is the message of the ARP request, right? And then the PC1 send out the message to the switch. When the switch receives this one, we have 2 functions, right? The first one is learning, the second one is forwarding. About the learning, we will associate the source MAC address in the table, and also to connect with the receiving interface. So at this time, to see the MAC address table again, you will find the MAC address is PC1 MAC address and the port is F0/1. So this is the first one. And then the switch have to forward the message out, right? And how to forward the message out? Because the destination MAC address is special, OF. OF means this is a broadcast message. So this message will be sent out to all the interface, but pay attention, except the receiving interface. So finally, when L2 switch records the source MAC address information to the MAC address table, later we will flood it. That means in this topology, the message will be sent out through the F0/2 and 3, two interfaces. And the next step, now on the MAC address table, we already recorded the information of the PC1. Then the PC2 and the PC3 maybe will respond to the data frame. Of course, maybe in some scenario, PC2 and PC3 will send out their own message. But anyway, L2 switch will receive the message from PC2 and PC3. Then the switch associates the source MAC address of the receiving interface. So when we check the MAC address table again, we will find the MAC address of PC2 and PC3 connect with the port interface of 2 and 3. So this is the process how to make your MAC address table bigger to get a lot of entry information. And the next step is maintenance. How to maintain the MAC address table? Now in our table, we have 3 entries from the PC1, PC2, and PC3. And about the maintain, the first one, if the switch port is down, the MAC address table will be deleted. The second one, if the PC doesn't send any packets within a period of time, and the default time is 5 minutes, the switch will automatically delete the MAC address table of the PC. So, if the interface of F0/3 is broken, then this MAC address will be deleted of the MAC address table. Of course, 5 minutes later, PC1 and PC2 don't send out any packet. We also will find the MAC address will be deleted. So this is a principle how to maintain the MAC address table. Why we have to delete the entry if we don't receive this message? Because this also is a limitation parameter of the switch. Maybe some core switch, we can have higher ability to record more MAC address entries. So this is a maintain. And another one, after we get the MAC address table, what's the function? Why we need so lots of resources? For example, the resources of ability, how many entries we can record. And also we need some resources, some places to record the MAC address information. That's because we need the MAC address to help us forward the message out. So the first one is if we receive a unicast message. Unicast message, for example, PC1 sends a message to PC2. And the special one is source MAC address is special for PC1. The destination MAC address is for the PC2. And why we say this is a unicast message? Because the destination MAC address is a unique one. And then the switch will send out the frame through the F0/2 based on the destination MAC address. We will directly take the destination MAC address to match the MAC address table from the first one to the last one. And then we will find that the PC2 MAC address is connected with the second interface. So finally, the message will be directly sent out to the PC2. So this is a unicast forwarding. If we don't have the MAC address table, or maybe your MAC address table is empty, what's the result? Okay, so let's say the process, we call it flooding. For example, if the destination MAC address is a broadcast MAC address, right? The broadcast MAC address means OF, or maybe some special for the multicast MAC address, or some unknown unicast MAC address. Unknown unicast MAC address means your destination MAC address is a unicast MAC address, but this MAC address not located on the MAC address table. So if the switch receives this message, we will do the function is flooding. We will send out the message through all ports, but pay attention, except the receiving interface. So PC1 send out the message to switch, and then the switch will do the flood. Finally, the message will be sent out to 2 and 3. Of course, if you have 10 interfaces, we also will send out to the rest 9 interfaces. So this is the function of the flooding. That's why we say why we need so many resources to record the MAC address information, right? Because if you have more MAC address information, you can forward out, for example, like some unknown unicast MAC address, we can only send out to one special interface, not all of them. Because if you send out all of the interface, finally, lots of message will be discarded. And this is a waste of the link resources. So we hope that the switch can help us to forward the message as soon as possible, not all the interface. It is required that your MAC address table entries is bigger is better. But we have the limitation of the MAC address table. That's why if some message will not send out the packet to the switch, after 5 minutes later, we will delete the MAC address entry. And pay attention, we say about the layer 2 switch, we can forward out the message and we can divide the collision domain. All the host or the terminal can send out the message at the same time if they located in different interfaces. But pay attention, layer 2 switch cannot divide the broadcast domain. Because about the broadcast message, when we receive it, we will directly do the flooding. If your network is very big, we will take lots of resources to forward out the broadcast message. So we say like this topology, if you only have layer 2 switch, all of them were located in the same broadcast domain. Okay. And how to divide the broadcast domain? We hope that broadcast domain can be smaller is better. We can use the other devices like layer 3 switch or maybe the router. Because layer 3 ports of the router or maybe switches can directly stop the broadcast message. I will not force the broadcast message about the layer 3 interface. So if we deploy the router and the layer 3 switch in this topology, finally we can get 3 broadcast domain. If the PCA sends out the message like ARP request, this is a broadcast message, and only the PCB can receive it, and the left of the layer 3 interface will receive it. PCC and PCD cannot receive. So in some scenario, we can make the resources more efficient. Okay, so this is the solution. And that's all about the L2 switch principle. And here we will have several questions. The first one is, An L2 Ethernet switch generates a MAC address table entry based on which information in a data frame receiving by a port. A is source MAC address or destination MAC address or source IP or destination IP. And the second one, once a MAC address entry is generated on the switch, it will not be cleared unless it is manually deleted. So the answer is true or false. When the switch, for example, if the switch has a MAC address table like this one, MAC address 1, 2, 3, 4, and connect with lots of ports, then if we receive the message from the first interface, and this is the source MAC address and destination MAC address information, what's the action? And if we receive the second message, what's the action? And the third one, if we receive the message from the first interface and the message destination is 007, what's the action? Please answer. And if you want to know the detail of these questions, if you want to get the detailed explanation, please follow the next video. Thank you.
Hello guys. Now maybe I think you already know everything about switch principle, right? So maybe let me have a brief summary for you. About the switch, we can divide it into two parts. One is a control plane and another one is a forwarding plane. About the control plane, the main work of the switch is to build the MAC address table. So how to build the table? When the switch receives the packets, I will record the source MAC address and add it into the table to make the table bigger. And after we have the MAC address table, then I will forward the packets according to the table. Take the destination MAC address to match the entries. And we have three actions: to forward the packets, discard the packets, or maybe flood. So the last part is about the broadcast domain. If the domain is too big, there is a resources waste. We have some solution. Maybe you can deploy the router or maybe deploy the layer 3 switch to avoid the domain. But it is too expensive. So that's part of the switch principle. Of course, we have the other technical solutions to avoid the domain. If you are interested, maybe you can continue to see the next video. Thank you.